Any question?
Oh, so when you talked about the gluconeogenesis,
Yes.
the utilization of lactate, please can you go over it again?
Sure. Just a second. Let me get you the question. Good. Now we have what? Gluconeogenesis. Now, gluconeogenesis is a process of producing what? Glucose from non-carbohydrate substances. Normally, it's carbohydrate that produces what? Glucose. And glucose are used to produce what? Energy. Using what? The Krebs cycle or the pentose phosphate pathway, then to go into the what? The electron transport chain. The energy is being produced. Usually 38 ATPs are produced from every single glucose that is metabolized. That's it, by the way. Now, that is what is happening in this person. So this person is saying that gluconeogenesis has been activated in him. But this person is doing what? Physical training or exercise. And you know, when you do exercise, you need a lot of energy, isn't it? When you are exercising, you need a lot of what? Energy. And again, too, you will need oxygen to be able to get more energy because it's oxygen that helps to actually get the required amount of energy that you need. So gluconeogenesis, or let me just say glycolysis, in the absence of oxygen will give us what? Lactic acid. In other words, they are using what? Anaerobic respiration in the absence of oxygen. And that is why those people that do exercises, they need to be drinking a lot of water because it helps them. And again, too, you realize that when you do exercise, there are so much muscle pains. The pains are coming from the accumulation of what? Acid inside these muscles or inside those muscles because they're not used to it. They are used to a normal, regular oxygen inside the tissues. But here's the case: because of exercise, have you asked yourself why you pant a lot when you're exercising? When you just run and you stop, because you need more oxygen to help you break down what? Glucose to give you more energy. That is the reason. That is the reason you do that. So basically, when you are doing exercise, the acid that accumulates in the muscles is what's giving you the pain. And that is called what? The lactic acid or lactate. 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 Sometimes, if you have watched our video, our previous video, you realize that they will tell you that somebody is exercising and has developed anaerobic respiration. When we say anaerobic, that means in the absence of oxygen. And in the absence of oxygen, it can go into Krebs cycle. It can go into the pentose phosphate pathway to give you the energy. It will use a different means, and that different means will end up producing what? Lactic acid. Doc, are you okay now?
Yes, I'm clear.
Wonderful. Wonderful. Dr. Yuma,
Yes, I'm good. I'm good.
you are great. Wonderful.
Yes, sir.
Wonderful. Dr. Yuma has been with us from the beginning, so there are so many things that I'm repeating, so I'm sure he's making things clear to him now. Esther.
Yes,
Okay.
Dr. Baha.
Yes. How is the night going?
No, the night is going okay, sir.
It's going okay. Is there any question you have for clarification?
I think I'm fine, sir.
You think or you are?
No, I'm fine, doctor.
You are fine. Okay. Okay.
Yeah.
All right. Great. Dr. Rabina.
Dr. Baha.
Yes. Talk to me.
Oh, Dr. Baha, please, I had a problem with question number 5.
Which is?
It spoke about, I think, ligamentum arteriosum after birth.
Okay. Okay. All right. You want me to do some drawings, isn't it? I will do. I will try and draw something so that you understand it better. Okay, it's not this one. This one, right?
Yes, please.
Good. Let me bring my drawing skills to you guys now. I want to bring my drawing skills. Those who will not like it, you're on your own. All right. So let's assume this is doctor's heart. So, doc, this is your heart, okay? Then in your heart, we have this, okay? We have that. Then we can talk about this over here. Good. Then we can talk about let's say the aorta moving from here to pass here. The aorta moving from here to come and pass here. Okay. Now, don't forget that over here too, we are having your lungs. Please, I hope, just try and then picture what I'm trying to draw. I'm not good with drawing, but just picture what I'm trying to draw. Good. Me now having what I don't even know what I'm even. Okay, so let me shade this one, so you know that this is. So this is your aorta. Good. Then again, and so this one is what? Your right atrium, your left atrium, your right ventricle, left ventricle. Over here is your aorta. Then don't forget again, your pulmonary, how do you call it? Trunk will be somewhere here. And this pulmonary trunk will be coming here. We're coming through to this place. Okay. To be coming through to this place. This is going into the lungs. So let me assume that this is going to the lungs. So this is the lungs. This is going to the lungs. This is going to what? The body. This is going to the lungs. Now, I know I've done so many plenty things, but please just pay close attention to what I'm trying to establish here. Now, blood will come to the right atrium. Then this is your tricuspid valve. Tricuspid valve. This is your tricuspid valve. Tricuspid valve. Then to enter into your right ventricle. From the right ventricle, it passes through the pulmonary trunk into your lungs. Then from your lungs, it comes back to the left atrium. When it comes to the left atrium, it goes through the mitral valve. This is your mitral valve. It goes through the mitral valve into the left ventricle, from left ventricle into the what? The aorta. Then into what? The systemic circulation. That is how it is done in a normal human being. Okay. Now, in newborn, or let me say in people before they are born, in people before they are born, or in, let me say fetus, okay. In a fetus, what happened is that they don't have this lung. In other words, this lung is not active, it's collapsed. So you ask yourself, how is the baby going to breathe? Don't forget, there's what we call the umbilical vessel. We have the umbilical vessel, which supplies, or in other words, that connects to the mother, isn't it? So when the mother has oxygenated her blood, okay, now the baby must also send oxygenated blood to the rest of his tissue, his or her tissue. But here's the case, he is a baby. There's no lung. So how will he send oxygenated blood? From the mother. From the mother. And that will mean that when the blood comes, it's also will enter into the right heart, isn't it? Enter into the right ventricle. Then it's supposed to now enter into the pulmonary trunk, enter into the lungs. But here, there's no lungs. So nature has made it that, or God in his infinite wisdom has made in a way that this blood that is coming from the mother passing through this pulmonary trunk will not enter into the baby's lungs, but rather it will enter straight into the what? Into the, how do you call it, the aorta. It will enter straight into the aorta. And how will it enter straight? That's why we have what? The ductus arteriosus. So over here, there's an opening. I've crossed over it. So let's say there's an opening here. Opening here. So the pulmonary trunk that's supposed to now send blood to the heart, so to the lungs, will now open into the into the aorta. To now open into the aorta. That's what we call it what? The arterios. Patent ductus arteriosus. Patent means what? Patent means what? Open. Open duct. So it's an open duct here. That is why in the baby, it will just come straight into that plate and enter into the aorta. And the aorta will now send blood to the systemic circulation of the baby. But as soon as you are born, that is why you have to cry so that your lungs will open and will start working. So if you don't cry, it means that you are still trying to depend on your mother for oxygenated blood. And here's the case, you are now out of your mother. You are now on your own. So your lungs must be open to be able to oxygenate blood. And that is where, since your lung must be open, that means this ductus must now close. It must now close so that the blood will not enter, you will not have a deoxygenated blood, because now there's no blood coming from the mother. So you now have a deoxygenated blood. It will not enter into systemic circulation. If it enters, it means that you're going to have what? Cyanosis. So this duct must now what? Close. It must now what? Close, so that easily blood can now enter into what? Into the lungs for oxygenation. Then it now come to the right atrium, left ventricle, and then into systemic circulation. So when such things are impaired, then there is obviously a problem. So guys, that is what you need to understand. And that's what we said, the ductus arteriosus connects the what? The pulmonary trunk and the aorta. Okay, that's what we said. It connects the pulmonary trunk and then pulmonary trunk and then the aorta. That's why your answer is what? Is E. Doc, are you on the same page now?
Yes, Dr. Baha.
Wonderful. Wonderful.
Thank you.
Yeah. Dr. Faustina.
Yes, Doc.
Yes. Shoot. Any question?
Yeah, please, concerning this same diagram. Actually, I have two questions. Concerning this same diagram, the ductus arteriosus, looking at the explanation, then where does the oval foramen comes in? Because I read somewhere that there is an oval foramen in the right atrium.
Good.
So
now,
where does that one come to play?
Wonderful. The foramen oval is here. That's the right atrium, and then the, how do you call it? The left atrium over here. So sometimes some of the blood that is supposed to now enter into the right ventricle, it will immediately enter into the left atrium. That is the deoxygenated blood, will now enter into the left atrium. When it enters into the left atrium, what will it do into? Of course, the left ventricle, then into the aorta, then it goes. You see? That means that it also keeps the left side of the heart also working. So the ductus arteriosus, again, is keeping the right heart working, whilst the ovale or the foramen ovale would keep the left heart working. So that means that when the blood now flows from this place to this place, it must move here, then it enters into the aorta, then it goes normally. That is why, again, when you are born, blood is not supposed to flow from the left atrium to the left, from the right atrium to the left atrium. When it happens like that, it means you're going to have what? A deoxygenated blood. So that place has to close. So this place now has to close. So to move to what? The right ventricle, into the pulmonary trunk, then into the lungs, before it now comes into the left atrium. Does it make sense now?
Yeah, it does.
Wonderful. Hogla.
Yeah, hello.
Yeah, you have another question, Faustina?
Yeah, the last question. You were talking about the location of the omental busa, and I wanted you to repeat it for me, please.
The omental basa or busa, whatever you want to pronounce it, is that it occurs below or posterior to the, how do you call it? Posterior to the stomach. It's posterior to the stomach. Posterior to the stomach. Posterior to the stomach. Uh-huh.
Thank you.
You are welcome, doctor. All right, so I open the floor. Dr. Grace.
Hi, sir. Sir, please, I want you to go back to the place where there was security stuff.
The what? The
About
security. Okay, the macular densa self.
Yeah.
The gesture. Okay.
Yes.
Okay.
Sorry, I
Sure.
didn't.
No problem. I think it's the question, right?
Yes, the question.
Good. So we are looking at what? Giant cells that have a secretory granules. Giant cells that have a secretory granule. Now, if you look at all these things, none of them is having a secretory granule apart from the gesta glomerula. And we are saying that the gesta glomerula is involved in the secretion of renin. And this renin is what causes what we call vasoconstriction. It causes vasoconstriction so that there will be increase in what? In pressure or in blood pressure. Okay, and again, to how does this renin get secreted? They get secreted when the macula densa asks them to do so. And I said the macula densa, of course, is not here, but the muscular densa is involved in sensing, like you begin to sense, or it is sensitive to what? To sodium. Sensitive to sodium. So when there is inadequate movement of sodium, this macular densa will sense it that there's no sodium in this person. That means that it's possible that there's no fluid in the person, or there's too much fluid in the person. Anyhow you want to define it, it is there. Okay. So when the demand comes that, guys, you need to be secreting what renin so that it can be what vasoconstriction and stuff like that. Macular densa will tell you to do so. Do you get me now?
Yes.
Wonderful.
Thank you.
You are welcome. You're welcome. You're welcome. Okay. Dr. Esther, today is your first time. How is the presentation?
Please, it's good. I understood everything.
You understood everything. That's
Yeah.
great. That's good. That's good. So you don't have any question today?
No, I don't.
All right. No problem. Dr. Yima?
Sir, are you calling me, sir?
Yeah. Any question?
No, sir. No, sir. We thank God. Everything is
Great. For those who are wondering who Yima has been with me from the beginning.
Sir, no.
He has been with me from the beginning. He was even one of the first people who were worrying me to start these tutorials. But I was dragging my feet. But later on, I realized it could help. So let's do it. But Yima has done very well. He has been with me and he has been very, very consistent with our meetings. And trust me, I won't be surprised if he destroyed the paper. All right, that is by the way. Hey, Rabina.
Dr. Baha,
My sweet lady, how are you?
I'm good, and you?
Great, I'm fine. Is there any question you want to be classified?
No, Dr. Baha, I'm fine.
Hey, today your mood here is down. Why? Are you hungry?
No.
You're not hungry?
No.
Okay, I was going to give you a hug, but since you're not hungry, that's fine. Okay. Dr. Faustina, don't get jealous. This is a normal thing. Don't get jealous, Faustina.
Actually, I am, but I won't talk much.
Please don't talk much. Is there a question?
Yes, please.
Sure.
The question on the common synovial sheet.
The synovial sheet, yeah.
Yeah. Can you please go over it for me? Because when I was looking at the synovial sheet, I saw that it was like connecting the digiti minimus and then the two other fingers closer
Yes,
to.
yes, yes. But
I
it's
was
more
wondering-
pronounced. It's more pronounced on the, how do you call it? The digitus minimus. It's more
okay.
pronounced. It's more pronounced over there. That is over here. That's the question now is, what is the most probable? Of course, it could be other places, but the most probable one would be where it has a larger surface area, okay, or where they are accumulated or they are found much. And that's over here. We easily say, this could be suffering from what? The little finger or the fifth finger, whatever you want to pronounce it.
All right. So.
Aha. Great.
I didn't get the question on what lymph nodes of it, like lower extremity something. I
Come
think the
again.
answer was superficial inguinal.
Come again. Come again.
The question that had the answer to be superficial inguinal.
Yeah.
I didn't really get the
Okay.
explanation.
The explanation. So what I was just trying to say is that when it comes to the inguinal lymph node or drainage or lymphatic drainage, they normally passes through the superficial inguinal lymph node. They like using the superficial inguinal. I'm coming. That's why sometimes when you have a leg injury. Now, when we say deep means it's inside deep, so you don't even see that there's even a drainage, so you don't see any swelling. But the superficial one, obviously, you can see that if you put your hands around your groin area, you realize that there's some node over there. Yima, I think your microphone is on, so mute it. Aha. Good. So I think there's a question. Aha. So good. So now we're having what? Two things. Either it is deep or it's superficial. But mostly when it comes to the lower extremity area, the lower part of the abdomen, they all drain into this superficial inguinal node or lymphatic system. That's what they all drain into. Okay. But for the deep, it's for deep, not really much of a work compared to the superficial lymph nodes. I hope now it's clear for you.
Yes, please. Thank
All
you.
right. Great. Yes. Faustina.
Sabaha.
Dr. Tan, yeah.
Yes, please.
Yes.
No question. Yeah.
Oh, okay. Good. Hogla.
Doctor,
Yes. Any question?
please, the nerve around the axillary, I didn't get that one.
The axillary nerve.
Okay.
I'm coming. Is it a discussion?
Yes, please.
Good. So we are saying that there's a pain in the humeral articulation. That's the shoulder joint. Okay. The shoulder joint. And there's pain over there. And the person cannot move the arm. The person cannot move the arm sideways. Away from the body. So what nerve is damaged or could be affected? And we are saying that if we have talked about the muscles, definitely we did something like this in our previous presentation. That was what? Deltoid muscles. So these deltoid muscles are supplied by the axillary nerve. So if there's a pain there, that means that axillary nerve is the cause of that pain.
Okay.
Erabina.
Dr. Baha,
Yes.
please, can you take this question for me?
Sure.
The occipital frontanel, the closure of the occipital frontanel, is it 3 months?
Yes. For the occipital, 2 to 3 months is supposed to be closed.
Okay.
Then for the frontal, is it frontal? Yeah, the anterior frontal, it's supposed to be closed 7 to 18 months. That's 1.5 years.
Okay.
Yeah. Another one again.
And then there was one question on the superior lobar bronchus, the right superior lobar. Is it apical, superior, and posterior?
Yes, apical. Hold on. You're confusing me. Let me get it for you.
There was a second one I didn't get.
I'm coming. Let me search for your question. Let me look at it very well. Just a second. Again, apical. Yes. Yes, it's apical, posterior, and anterior. That's the superior lobe. The superior lobe. Because when substance gets into the lungs, they end up over there. Is there another one again?
No, please. Thank you.
You are welcome, doctor. You are welcome.